Hi students, welcome to this course, PLC Automation, an introduction to programmable logic controller. I am Professor Yao. Numbering system and PLC number conversion functions. Objectives. The keywords. The binary counting system, from binary to decimal, vice versa, binary coded decimal, binary to BCD, octal systems, hex systems. Gray. American Standard Code for Information Interchange, ASCII. Extended Binary Coded Decimal Interchange Code, EBCDIC. Objectives. At the end of this chapter, you will be able to explain the basis of the binary counting system, convert numbers from binary to decimal, and vice versa. Explain the base of the binary coded decimal BCD system, convert numbers from BCD to binary, and vice versa. Program a PLC for binary to BCD and BCD to binary conversion. Explain the base of the octal and hex system. Convert among the three numbers systems, decimal, octal, and hex. Describe the three coding systems. Gray, American Standard Code for Information Interchange, ASCII, and Extended Binary Code Decimal Interchange Code, EBCDIC. Introduction. The keywords. Hexadecimal, larger PLCs, handheld calculator, various personal computer programs, numbering systems. This chapter deals with some of these numbering systems, including binary, BCD, octal, hexadecimal, gray, ASCII, and EBCDIC. The basics of each system are explained, and the conversions from one system to another are illustrated. The purpose of this chapter is to give you enough background to handle any numbering system that you may encounter on larger PLC or in the future. Various texts are available that detail the use of all numbering systems. Note that this chapter does all conversion longhand. Actually, actual conversion can be met easily with a moderately priced scientific handheld calculator. Various personal computer programs for larger numbers are available. Numbering system, decimal, binary, and BCD. The keywords: the decimal numbering system, digital computers, integrated circuits, central processing unit. As the result, the decimal numbering system, which uses a base of 10, is the one we use every day. The decimal system is said to have developed by tens because the originators had 10 fingers and so could easily count to 10. Above 10, another person or means had to be used to keep track of the tens. If the count was over 99 and less than 1000, a third means was needed to keep track of hundreds. Thus, decimal system was developed. When digital computers were developed, they were designed to count by twos. Their counters were either off or on. Therefore, the base of the computer counting system is 2, instead of the 10 used in the decimal system. With the advent of integrated circuits, IC chip, hundreds of binary on-off switches can now be found on a single IC chip in computers. Or PLC work internally in a binary system because they are IC chip based. Since outside information is decimal or BCD, a conversion to and from the binary used in the PLC CPU is needed. Figure 13.1 shows a comparison of the interpretation of a decimal and a binary number. The numbers are arbitrarily picked for this illustration. There are 10 possible count values, 0 through 9, in each decimal position. For the binary counter, there are only two possible counts, 0 or 1. This picture shows decimal and binary system comparison. Typical decimal numbers, typical binary numbers. This picture shows decimal and binary value comparison. As a result, for binary we must move to the next bit or slot after we reach 1, not 9. As in decimal, the binary number has a decimal equivalent value of 4 plus 1 or 5. Figure 13.3 illustrates the counting slot or bit status for some typical binary numbers. The more bits you used, the higher you can count. The maximum decimal equivalent count is given for each example, 1 in all bits. the equivalent decimal values for the given binary bit patterns are given also. This picture shows typical binary numbers and the decimal equivalent. 4 bits, 8 bits, 12 bits, and 16 bits. The maximum value if all bits are 1. 15, 255, 4095, 65535. For figure 13.4 gives some examples of conversion from binary to decimal. 4, 8, and 12-bit numbers are shown in the example. Different numbers of bits are converted similarly, starting from right to left. Binary to decimal. Figure 13.5 illustrates the opposite conversion from decimal to binary. Basically, the procedure is to find the largest number in the digital columns that is less than the decimal number being converted. 81 is placed in that binary column. This picture shows the decimal to binary conversion. Next, subtract the column's binary or decimal value numbers from the decimal number being converted. Then move one column to the right and apply the same procedure to the remainder. Keep repeating the procedure until the remainder is 0. A related number system used often in PLC is the binary coded decimal, or BCD system. The key to BCD system is to utilize 4-digit bit for each single decimal number of output or input. A commonly used BCD system contains 4 decimal numbers and then can display decimal value from 000 through 9999. The 4-digit decimal number is then represented by 4 times 4, or 16 bits. Figure 13.6 shows some typical decimal numbers and their BCD equivalents. For comparison, the binary values are also shown in the table. PLC CPU function in binary, not BCD or decimal. If the PLC received a BCD number from an input, some wheel, a small rotary device set to 0 through 9 by rotating it with the thumb or finger. It would interpret the number as a binary number. This picture shows decimal and the BCD equivalent. The BCD input number must be converted to each binary equivalent. for correct PLC central processing unit operation. Your PLC may do the conversion automatically. However, in most cases, you must program in the BCD to binary conversion for input. For outputs, you program binary to BCD conversions. Figure 13.7 shows a simple example of required conversion. The PLC is required to take an input value in BCD and then multiply it by 0.5. The resulting number is then displayed in the BCD on an output LED readout. Since the PLC functions in binary, the input BCD value must be converted to binary before internal processing can take place. Then, the converted binary number is multiplied in binary by 0.5. This resulting binary value is then converted to BCD for output to the display. This picture shows the BCD to binary and the binary to BCD PLC processing. Homework: handwriting all keywords and submitting them to Course Facebook. Just do the online quiz and see you next time.